Okay, now we saw how the public subnet, the server, the web server in the public subnet can access to the internet, right? And we created the custom route table and custom internet gateway, and through that we are able to connect the public server to the internet. Now, what we'll do here, if we see our private subnet, we have a private subnet which does not have access to the internet. In our private subnet, we have created one EC2 instances, and that is in our case, it is DB server, and we have this DB server. We don't have the public IP. Then how we'll connect this DB server? Okay, through the private IP from outside wall, we cannot connect to the server. So how we'll do that? So simple, what we have to do. First thing is, let me exit out from here. So first thing is, we have to copy the certificate file, the PEM file, .pem file, right? The key to the public subnet. So let me copy this one, scp-i. Let's just try to understand what I'm doing. If you're not able to understand, just ask me, okay? So certificate, I'll just give us a c2-user, enter it. Now what I have to do here, simply put the IP address of the public instance, the web server, okay? From the web server, I can able to access the DB server using the private IP address, okay? Using the private IP address. Now let me just copy these things. I'll do here, paste it here. Now I have to provide this to somewhere, like I have to just put it to the home directory, right? I have to put it to the home directory. Now, dot, enter, good. So our certificate file has been copied. Certificate file has been, do you have any doubt on this command? No, right? Good. So I just copied this certificate. Now let's connect to the server now. And we have in this home directory, we'll have this certificate copied. Got it? Now, using this certificate file, ssh-i, provide this certificate file from the public server, from the web server, using the IP address, private IP address, we can able to connect the server. Yes. See, we can able to connect the server. Okay, what happened here? What IP address I chose? Wrong. It's not. We have to choose the DB server one, right? Copy. Just provide the user here. See, we are able to connect to the DB server. So what happened here? Our database server, the private subnet, right? If you see this diagram here, the private subnet, let's remove this access. We have not created now, right? All these things we have not created. Let's remove this. Okay. Now, how we connected this one? We connected through the public subnet using the private IP address. Now we connected this from public subnet to the private subnet using the private IP address of the EC2 instances. Now, if I do here, simply just try to update the system. Suppose I'll use sudo yum update hyphen yes. Okay, so what will happen? So it will fail, right? Because it will not have any internet connections. This private subnet, the private subnet does not have any internet connections. Does not have any internet connections. It is simply isolated and sitting inside the VPC, does not have access to the outside world. That's why we are not able to upgrade it. See, it is just simply failing, right? Connection timed out. That's good. Now we saw we don't have any internet connections to our private subnet. So how will get internet access to the private subnet? How will get internet access to the private subnet? Now, if I go here, let's go ahead and create our NAT gateway. So what is the NAT gateway, guys? Can anybody answer it?
Sir, in NAT gateway, we have connect the private subnet to the internet connection.
Okay, so NAT gateway is the network access translator. Okay, so through which what we can do, we can connect to the internet and provide access to the private subnet. From the public subnet, we can access to the private subnet using the NAT gateway. Through the NAT gateway, we can route the internet traffic to the internet gateway. Okay, so let's go and check the NAT gateway. Network address network address translation. Okay, gateway is a highly available AWS managed service that makes it easy to connect to the internet from the instances within a private subnet in an emergent VPC. Okay, so by using the NAT gateway, we can able to connect to the internet, okay, private subnet. Okay, so let's go ahead and create a NAT gateway. So if I go and create NAT gateway here, go to the NAT gateway section. We don't have anything. Let's go ahead and create one NAT gateway. You can give us same thing, custom NAT. Okay, and you have to where you have to create the NAT gateway, in which subnet you have to choose. Okay, in which subnet you have to create. So what we need, I need this one to be placed on my public subnet. So now if you see this diagram here, I'm going to put this one in the public subnet here. Okay, I put the NAT gateway. Now let's go ahead. I put it here. So connectivity type, select a connectivity type, NAT gateway, public. Elastic IP allocation. So here we have to create one elastic IP. So what is elastic IP? Before creating this elastic IP, you should know what is the elastic IP. Anybody can answer what is elastic IP? Let's do that one first. Elastic IP. It's not this one. It's the search option here. Search for elastic. Okay, so what are the elastic IP addresses and how do I use them? Okay, if you see here, an elastic IP address is a reserved public IP address that you can assign to any EC2 instances in a particular region until you choose to release it. To allocate an IP address to your account in a particular region, you have to choose which region your EC2 instances are there. So you have to associate the elastic IP. And there, let me tell you one more thing about elastic IP. So elastic IP is a static IP. Okay, elastic IP is a static IP. It will never change until unless you delete and recreate it. Okay, the IP address will be only one static IP address. So as many as EC2 instances you create and delete, but you will have one IP addresses will be assigned to your EC2 instances. So you would have noticed, right, whenever we create EC2 instances, by default, what happens here? It creates a dynamic IP addresses automatically assigned to our EC2 instances, right? Even though you stop your instances and restart it, another IP address will be attached to the EC2 instances. So dynamically it gets changed and it will be irritated if you are going to stop your machines for some time and again create it. Dynamic IP addresses is not good for your business purposes, right? So that's why you have to go for elastic IP address. And it is static, even though you stop, you delete, you recreate, everything will be any instances if you create, and you can attach simple the IP address, elastic IP, and that's the static IP address. One point. Another point is elastic IP addresses. They don't charge if you use elastic IP addresses. Remember, they don't charge if you use elastic IP addresses. The other way, if you don't use it, you created, but you are not using it, they'll keep you charging for that. Okay, so let's go ahead and check for the pricing, right? Okay, it's not the pricing here. I think some pricing will be here. It was understand elastic IP charges. Let's see this one. Okay. So elastic IP does not include charges as long as the following conditions are true. See, an elastic IP addresses, as I was telling just before, right? An elastic IP address does not incur charges as long as all the following conditions are true. One is the elastic IP addresses is associated with an EC2 instances, right? So if it is already associated with an EC2 instances, they'll not charge you. And the instance should be in the running condition. Okay, the instance associated with the elastic IP address is running. If you stop it, they'll keep you charging. That means if you created the elastic IP attached to the EC2 instances, you have to keep the EC2 instances running, or else they will keep you charging. So what will happen here? If your EC2 instances is running, they'll not charge you with elastic IP address. However, they will charge you as part of the EC2 instances, right? They'll charge you as part of the EC2 instances. If you stop the EC2 instances, what will happen? They'll not charge you for the EC2 instances. However, they'll keep charging on the elastic IP side. Both the side, they will be charging. Okay, so you have to understand the concept, how it works. So the instance has only one elastic IP address attached to it. One instance obviously will have one IP addresses. So let me just ping you all this and just go through, guys. And this is very interesting topics and all. So to make notes on this. One second. Where is the chat option? Okay, I'll just ping you in the chat. Good. Now you understood about the elastic IP. I'm not going to spend more time here now. Let's go ahead and allocate one elastic IP address. We don't have any elastic IP address here. Allocate. What happens here? It automatically, once I created allocate elastic IP, what happens? It automatically created one elastic IP and added to the EC2, sorry, NAT gateway. And you can see here, it is having 3.7.42.13 is the IP address. Okay, got it. Now it's added. That's all. We have to only just add the elastic IP. Create the NAT gateway. So it will take some time, guys. It is in pending state. Just wait for a few seconds. Let me. And whatever things, services you are creating, guys, make sure you delete everything after your lab classes, okay? Or else they'll keep you charging you on this. Okay, let's refresh this page. Let's make sure that this is created. Okay. It's still pending. Okay, just wait for a few seconds, guys. I'm just muting. Okay, it's still in pending states, right? Okay, it's now available. So if I see here the elastic IP, right? It's created and it doesn't have a name. That's okay, no problem. And because I just simply created an allocation because I have not created the elastic IP, right? So I can provide a name like my EIP, my elastic IP, subject changes. Okay, got it. And all these are the IP addresses and all for the elastic IP. Let's go ahead for the NAT gateway. And this NAT gateway, right? If I just go ahead and for details, we can find what are the things being added. So we have this elastic IP addresses attached to the NAT gateway. Now, what we saw here in our diagram, based on the diagram, we have this NAT gateway created. Okay. Now, what do we have to do? We have to provide access to this NAT gateway, right? Through the NAT gateway. So what we'll do now, let's go ahead. Okay, what we have to do now, go to the route tables. Got it? Now, we have our custom route table. Also, we have one main route table. See, how we'll see whether it's a main route table or not. See, any route table is a default route table as part of the VPC creation will be the main route table. You can see here main, yes, the default one, but the custom one which we created, it's not the main route table. This will be helpful in our automations part in our Terraform class. Okay, in whenever we do these classes, Terraform classes, you need to understand how to edit the main route table, right? By using the filter options and all. So you need to understand what is main and all, and what will be the options and value for that. Okay. Now, what do we need? We have to modify this main route table. Through this main route table, you can see this diagram. Through this main route table, we are going to provide access. This part we have to establish. All right. Now let's go ahead to the route table, main route table. So what do we need? First, go to the route side here, edit, route, and make sure this is the custom VPC. Okay, edit route, add, and here what we need, don't give this public here, don't give this public part. So what we'll do here, we'll just have to provide the private subnet ID, right? It is 10.4.2, right? This one. Okay, now select the NAT gateway, custom NAT gateway, done, save changes. Good. So we have added this private subnet. Now what happened? This private subnet is added to the route table through this NAT gateway. Okay, if I go here, this one is added to the NAT gateway. Now, what do you need? We have to associate the subnet with this route table. Okay, already we have one association is pending. The other one is already associated with the custom route table. That's why it is only showing only one private subnet, right? So I'll just select this private subnet, say association. Added here, association is done. No more subnets are pending. All these things. Public one is associated with the custom route table, and the private one is associated with the main route table. Got it? Done. What we'll do now? Route options is done. Route table, everything up, all the options are now done. Right. Now what we need, this part also is done, right? This part is also done. But from the main route table, we don't have access to the internet gateway. Okay, this part is not there. Let's go ahead. We are still connected to the private subnet, our DB server, right? This 229 is our DB server. Now, if I do same command again, let's see what happened. Still, we don't have the internet connection, right? If you see here, this part is not established. So how we'll do that? Go ahead. The route option, right? So here what we have to do.
Sir, we have to put the public IP address of the subnet.
Where? Here?
Yes, sir.
Okay, no. Here actually we are just adding this private subnet. Okay, so okay, let me change this to public and see. So it automatically deleted this one and recreated this local public one. Okay, now if I go ahead, what will happen here? We directly gave this public IP addresses. That's why we got the internet. What will happen here? Instead of public, we actually have to restrict the access to the only private subnet. Okay, so how we'll do that? That's when we give public, we get access. What we have to do here, instead of providing this, we need to provide the private IP address of the DB server. Okay, here public is not good idea always to provide public access to the NAT table. So what we'll do now, simply go ahead and edit the route table. One second. I'll go to the VPC here. So now we saw we have this public access, right, to the internet. What we'll do now, remove this part, provide the IP address 32. This way you have, if you don't give 32, it will not allow you to add it. Okay, provide 32. Now let's, okay, let's remove completely, save the changes. To again, let's do install something. Sudo yum install git hyphen. Okay. What happened? We did not remove anything. Okay. Okay, connection timed out. Okay, we have connection timed out. So it is failing. It's not able to install anything because the connection is timing out. Fine. Now what we'll do, let me come out of this one. Okay. Add again, edit this route table one more time.
Hello, sir. Can we add here CIDR range of the public subnet?
No, no, no. That will not work. Okay, so let me just add the public IP 32, provide the NAT gateway here, save changes. What happened? Route destination does not match with the subnet CIDR block. So see, this is how it is not working. This subnet range is not working. So you're talking about the subnet range, right? Let me just provide this subnet range to suppose 24, right? This is the subnet range we have provided for the private one. Save changes. Let's install it. Okay, still we are getting connection timed out, though it is allowing you. So what we saw here, if we add the private IP addresses, here you have to just provide the range. If you're providing only the private IP addresses, not working. Okay, let me just add one more table here. Provide 32. Not gateway. Add it. So what it says, the route destination does not match any subnet CIDR block. So you have to provide subnet CIDR blocks. So single IP address, remember single IP addresses, we cannot add it. Back, remove it. And we can add here public and gateway. Done. Save changes. Okay, we added the public one now. So all these public ranges, all the ranges of IP addresses can be worked. Now if I go ahead, let me clear this section. Okay, it will be there as part of the, so I'll just install another one, HTTPD. Okay, why I need HTTPD? I don't need HTTPD, right? So let's see if the MySQL package will be available here, because this is the database server, right? Good. So MySQL is now, MariaDB is now installed. So this is how you have to create the NAT gateway and provide access to your server. Okay, now you understood clearly how you have to do the setups. Now we have the NAT gateway and we have this entire connectivity through the NAT gateway we connected. So you know how to connect the private subnet from the public subnet, right? By using the private IP addresses and the key and the server key. So once you connected, you need access for any internet activity within the private instances, like the patching, upgrading, or installing any libraries or anything in the database server. But how will restrict the network access. So far we have seen the security groups and all, right? Security group accesses and all. So how will use the network access control list? Now all the things as per the diagram is working perfectly, right? As per the diagram, everything is working perfectly. Here in this diagram, I have not added the network access control list. It will be extra level of security to our network, right? So what we'll do, let's go ahead, go to the network access control list here. So we'll have, if you go to the security groups in the security tab, we'll have multiple security groups, but for this our custom things, we have 2, 3, right? One default and these 2 we created under this security, under this VPC, right? Now let's go ahead for the network access control list. We have 2 network access control list here. Okay, one is the related to the default VPC and one is the custom VPC, and this is main default. Yes. Okay, now what happens here? 2 subnets associated with this network ACL. Now, if I go to this here, inbound rule, what this network access control list we had discussed, it will be in the incremental order, right? If I go to the NACL, right, NAT gateway and network access control list privately, where it is VPC endpoint, direct connect. Okay. This access control list is a set of rules defined for controlling the network traffic and reducing the network attack. ACL are used to filter traffic based on the set of rules defined for incoming and outgoing of the network. And it is an optional layer of security for your VPC that acts as a firewall for controlling traffic in and out one or more subnet. Okay, so, and we have seen this, all these details, right, related to the NACLs in our previous classes. And if you still need, you can just go and watch that video. You'll get more details about the NACL. Okay, now what I need to see this subnet associations, how we'll do that. So there is a questions. If you, in your last class, if you remember the things, by default, okay, when you create the custom NACL, what will be the inbound rules? By default, what will be the inbound rules? If you create a custom NACL, by default, what will be the inbound rules? So this is our default. This is our default NACL, right? This is our default NACL. Let's go ahead and create one and see what inbound rule. If you see here, first rule is 100, all traffic and source public IP, right? It will be traffic, all traffic and source public. It is allowed, public allowed. So if I go ahead and create my custom network access list, right? I just give my NACL, okay? Select VPC, custom VPC. That's all. Create network access control list. So it's created. Default, no, obviously. Now if I go here, no subnets associated with our custom VPC yet. Sorry, custom NACL yet, right? So one outbound rule, one inbound rule. Now let's go ahead and check this one, how it looks like. See, by default, if you create the custom NACL, it will be denied. It will deny everything. What you have to do, you have to add the rules if you want to provide access. Okay, if you want to provide access. Now let's delete this one. I'll show you in a different way. Let's delete this one. I'll create if needed again. So let me delete this network access control list. Delete. Okay. Now let me come out from this private subnet, sorry, private database. Come out from here also. Okay. I'm into my my laptop. Okay, my one terminal. I'm not connected any subnet. So if I try to connect this server, we can able to connect now, right? Because it is the default NACL has permission of allowing everyone. Allow everyone. Okay, let's edit this inbound role. And I'll just try to remove this, or let's deny.
Hello.
Yeah.
Sir, the default one is automatically associated with our subnet, or
automatically associated with the VPC and the subnet. So okay. As we said, right, whenever we create the custom VPC, the default NACL will be created, NACL will be created, and that default NACL, if you see, automatically 2 subnets will be associated with that. But let me cancel these changes. What I'll do here, if I go here, subnet associations will have these 2 by default is associated with this NACL. Okay, by default it is associated with this.
When we create our custom NACL, then we associated our VPC. It's automatically removed from the default one.
No, we have to associate. We have to associate.
Yes, sir. We have to associate, but the default one NACL automatically de-associated with the two subnet.
So, no, automatically it will not be de-associated. Okay. You have to remove those and associate with the custom NACL, whatever you will create. Okay. We'll see that one. Okay, we'll see that one. So you can see here it is grayed out and it is not giving any options to remove this one. Okay, to remove any changes from the default one. So if I go ahead and change the route options of this table, I'm just changing this inbound rule. Set to deny, save changes. Okay, deny and save changes. What is happened here? We can say deny everything. Now, if I go ahead and connect, see, we are not able to connect because the network access control list is now blocking everyone. No. Okay, so we don't have access now. Now, let me just go ahead and remove this. You guys do practice at home, right? Whatever we are doing it, just try to play around all these things, okay? Try creating network access and see. Okay, now what happened here? I have denied here. Okay, now go ahead and create one network access list, custom network access list, okay? And we'll see what Jyoti was asking for associations. So I'll just go ahead and create one NACL, custom one, add it here. Okay, save, create network ACL. So we don't have anything associated with our custom. By default, two subnets are associated with our default NACL. Okay, so let's go ahead and edit this subnet association and see, by default everything is denied, right? Everything is denied. So what I'll do here, subnet association, go to the subnet association here and edit subnet association. We can see here it's giving option to which one to put in the custom NACL. I'll put suppose this public one, save changes. Now if I see here, I have one subnet associated with this custom NACL, with this custom NACL. If I go and check the inbound rules, we have everything is denied. You have everything denied. Fine. Now let's go ahead to the network SL and check here now. See, the default one is having only one and the custom one is having one now. Now, Jyoti understood, right? How you have to do the associations. Yes, you have to do it automatically, not get associated. If automatically get associated, then no point of, there will be no security, right? You have to focus on the security. So it will not never the associations happen automatically. You have to do it manually, one by one. Now, the association is happened. So what we have to do, again, I associated the subnet. However, if I connect, it will still fail because the custom one, the rule is given deny. Everything is deny. Let's go ahead, edit the inbound rule, add new rule, provide. Remember, it's incremented, starts with 100, 200, 300, 400, 500. The rule starts like this. Okay. Now, custom TCP, I can just give suppose SSH. Got it? Or what I can do, I can provide all traffic. All traffic. That means all ports will be opened. All ports are opened. If you want to specify any port to be opened, then you can provide that also. Now, I gave this one, allow, save, changes. See, allowed, save, changes. Let's come out here. Okay. Allowed there, let's do changes. It's still not working. It's still not working. Why?
Sir, we are not assigned the outbound rule because in NACL we have both. We have to both assign inbound and outbound. But in our security group, we are if we assign one, it's by default it will take the outbound rules.
Exactly. So we just set up the inbound rule, means we allowed the access, but from where, how we'll connect the internet. So we don't have outbound rule set up in NACL. That's very good that Jyoti remembers. Like security groups, we have to only set up the inbound rule. Outbound is not required, but in case of NACL, we have to set both inbound rule as well as the outbound rules. Okay, so let's go ahead and edit the outbound rules. Let's give it as 100. All traffic. Okay, allow. Let's come out from here. Now, save changes. So both inbound and outbound rules we have added in our custom NACL. Okay, if I go to the default NACL, let's go to the default NACL. If you see the outbound rules, it's also been the same, inbound and outbound. Okay, so you have to also do the same things. Now, if I go ahead and do, see, we are able to connect. Now, this is how you have to add extra level of security to the networks. Now, let me remove this public access and provide only specific IP addresses. In security group, you cannot provide specific IP addresses. Here, you can block and allow, disallow by using selecting the IP addresses. Okay. Now, if I go and change these rules, go to the outbound rules, edit. Okay. Instead of public, I'll just provide the public IP address here, the destination of the one, right? Go to this one and get the public IP address here. Put things here, /32, right? Now, save changes. Do the same thing for inbound. Got it. Okay. So I provided only the outbound rule. I provided the IP address of our web server only. That means in the VPC, we can able to connect to the web server only, right? And inbound rule. So whatever the inbound rule means, the servers having this IP address only can connect to this network. Okay. Now, if I go ahead and exit out from here, sorry, as I changed the NACL, so it got stuck. Okay. So what do you have to do? You have to simply, let's just open this. Okay, it's blocking now. Allow outbound rules. Also, it has this public IP addresses. Anything you remember, Jyoti? Okay, so what happened here? The destination we have given us the IP addresses, particular single IP addresses, which is not allowing me to connect. Now we'll see how we can just change and give particular. Okay, we cannot simply provide here. What we can do, we can write another rule. We can write another rule 200, and there we'll just block this one. Okay, let's quickly do provide 0. Zero here. So it changes. I'll just show you in a different way. Right? /0. Save changes. Okay. Now what happened? I just provided here. Okay. It's connecting. That's fine. Now what I'll do, I'll just create another rule. It's called suppose 200. I'll just create another rule 200. Okay. And all traffic, that's fine. And provide the IP. Provide the IP address 32 here and deny. Let's see the precedency over the rules. Okay, I'm just showing the precedency, how the precedence happens. Save changes 100 outbound rule. So 200 all traffic, provide this, deny. Save changes. Done. We added 100 all, but in 200 rule, we added the public IP address which needs to be denied, right? Now, if I go ahead and connect this, what will happen, guys? What will happen? If you remember this part, I'll just come with here, okay? Let's go ahead, connect. It's connected. So why? If I go to this point here, our rule number 100 has more precedency, means this comes first. It is allowing everyone to connect. But the second rule, 200, is giving and blocking only the IP addresses. So the precedency takes over by the rule number 100. Now, if I go here, so as we have a point, we can block IP addresses using network SL, but not using the security groups. Okay. And for your point, Jyoti, each subnet in a VPC must be associated with network SL. If we don't explicitly associate a subnet with network SL, the subnet is automatically associated with the default network SL. Okay, so whenever we create, it will be automatically added to the default network, not to the, it never gets automatically associated with the custom ACL. You have to manually add it. Okay, explicitly you have to manually add it with the custom ACL, with the custom network ACL. Default one, it comes with the VPC, and obviously whatever the subnet you create as part of the VPC, it will be part of the default ACL. So what happens? See, the NACL contains a numbered list of rules that is evaluated in order, starting with the lowest number rule. Starting with the lowest number rule. So it will first start with the lowest number rule. Now, if I go ahead and just modify these things, right? Let's go ahead. Let's little bit change here and there. Okay. Control C. I put it here. Deny. Let's allow. Okay. And I'll just put it public. In 200, we gave public, and here I gave this one. I blocked this IP addresses, right? Save changes. Save changes. Done. So okay, it's denied. Outbound is denied or not? Okay, it's an allowed, right? Let me change it. Deny, allow, save changes. Done. Let's go ahead. Still the precedence, what takes over? Why? Okay, it takes over this public IP addresses, right? 1 second. Denying everything. You need to see it out. Okay. So this is a task, guys. Do R&D and just keep adding these IP addresses and just play around with it. Okay. And we'll see how it is working. Okay, it is stop now. That means it will not work. Okay, this will not work because everything I denied, right? Everything is denied. That is simple. It will not work. Now you just understood how the network access control list works, and it is for blocking the particular IP addresses, which is not possible as part of the security group. So the task is, guys, for you just create the custom ACL default ACL, see how the association works, and manually associate with the network custom network access control list. and try to create the different kind of rules and play around with the different IPs and all. Okay, that's all, guys.
Sir,
Yeah. Yeah,
sir,
Jyoti.
sir, in our security group, we have provided 80 port, but in NACL, we are not provide the 80 port. Can we access here the net or not?
Yes. So how? Because here we provided all traffic. We provided all traffic. Okay. Let's do this demo quickly. Okay. I just allow everything. Save changes. So we have, as I said, the type is all traffic. All ports are available now, right? At access. So what we can do here now, anyway, the security group, we have already given the port number 80, right? And we installed HTTPD in our server. Now let's connect. We are connected now, and our HTTPD server is system CTO. HTTPD is not installed. I'll quickly install it. Sudo yum so sorry. Okay, so it's installed. Now if I do, so it's not running. Now let me start it. Start. Running, right? So if I go ahead and access this one, the web server, we can still able to access it. See, the web server is working. Apache server, we can see the Apache server. Because we have already, for these instances, we have added the security group with the port. So if I go to the instances here, the security group, we have this particular security group, the port number 80 is allowed. Okay, now let's do some blockage here in the network access control list. Okay, I'm going to just quickly edit something here. Let's remove this one. So allow, and instead of all traffic, I'll just give, suppose, SSH only. Save changes. Outbound. Let's see how it works, right? Remove. Allow. Instead of all traffic, I'll go with SSH only. Save changes. Okay. Let's copy this one. Remove this page. Go here. Paste it. See, it's just, you can see here, the cursor is just running, right? It's not allowed. So here in the network SCL also, we can block this port. See, we only allowed for SSH. Port number 22 is not allowed. Okay, now let's stop this one. Stop this one. Go ahead, edit inbound rule. Port HTTP. Where is HTTP? HTTP. Okay, HTTP here. Okay, save changes. Save changes. Okay, so I added this HTTP port. If I go ahead and refresh it, sorry. Just wait for some time. Site cannot be reached. Okay, so now you saw this one, how it works and all for this port also, right? If I give all traffic, it will allow this one. If I specify something, it's not allowing. Now do this task, your home, try to do for all traffic and try to provide some specific IP addresses and all, and try to see how it is working or not. Okay, that's all for the VPC things, guys. We are able to see, and the rest of the things like VPC peering and all, we'll see how it works in our upcoming classes. So VPC, everything is over with the AWS, and what we'll do now in our next classes, we'll